Welcome to Unit 2, Lesson 10, Multiplicity. Let's sketch some polynomial functions. Okay, what do you notice? What do you wonder? So today, we're looking at factor polynomials like we did in the last 3 lessons, but today we have polynomials that have exponents on them. So 3 of them have a 2 and 1 of them has a 3. So let us examine the shape, what's going on at the intercept x minus 3. Let us examine what's going on. So if we set x minus 3 equal to 0, we have to add 3 to both sides, and then we get x equals 3. That's our intercept for every polynomial here. Now, graphs 1, 2, and 4 have a square, and I'm going to write a note. And graph 3 has an odd exponent, so that gets a different note. But if you look at the graphs 1, 2, and 4 rebound back on itself or doubles back. It goes down, then it goes back up. For graph 3, you see the graph kind of worm its way through the intercept. It goes up, then it turns almost sideways, and then it goes back up again. So look for the note that will be written for each one, and then I'll come back and explain it. Read it. So when a polynomial has an even exponent on a factor, the graph will rebound. So that's what you see in graphs 1, 2, and 4 at the intercept. Now, looking at graph 3, when a polynomial has an odd exponent on a factor, the graph will worm its way through the intercept. And so now we can go ahead and look at the graphs, sketch graphs of the following functions on the next slides. All right, for the next one, we're going to sketch some polynomials using a description. Okay, so we have 3 factors. If we multiply the x's, x times x times x, we get 3. Our leading term is x cubed. If we multiply positive 2 times negative 2, we get negative 4. Negative 4 times negative 8 is positive 32. This is our y-intercept at 32. We got 3. So it should start low and go high. That's what the graph should look like. It should look something like that. Now, let's put our zeros. Our zeros, you had to change the signs. Why do we have to change the sign? Because x plus 2 equal to 0. You subtract 2, you subtract 2, you get x equals negative 2. So our zeros are negative 2, positive 2, and positive 8. So if we start low, we come up, and then come back down through 2 and up through 8, it should look something like that. You can always graph these to see if I'm right. I might be a little off in the hump where the y-intercept is, but that's okay. I'm getting close to the shape of the graph. But go ahead and put this in the calculator. Put all factors into y equals, into y1, and then hit second graph. You might need to change the window. So if you hit the window button and change your y max, let's see, 32 to plus 40 and y min to negative 40, you might get a better view of the hump of the graph. How do I know? My intercept is 32, and you should probably go a little bit above and a little bit below just to see if you can see the whole graph. All right, looking at the next one. We have x squared times x, which makes x cubed. But we got this negative out front, which means our leading term is negative x cubed. Our degree is still 3, but for negative x cubed, we start high and go low. Negative xi starts high and goes low. Now, this 2 squared means negative 2 is squared. Negative 2 times negative 2 is positive 4 times positive 2 is positive 8. So we're here. So put your factors in. X plus 2 is at negative 2. X minus 2 is at positive 2. So we're starting high and going low. We're starting high and is at negative 2, which is at positive 2, is doubling back. Starting high and going low. So what is it going to look like? Oh, this should be negative 8. I forgot about that negative out front. That's why I was looking funny. Sorry. So this should be negative 8. So it's going to start high. And then it's going to double back at 2. So it's going to look something like that. And you can always graph it again. Hit the same buttons. The only thing that's going to change is the factors. But you still hit the same buttons. Leave it at positive 40 and negative 40. You'll see more than what you want. But you can always change the windows down. Okay, looking at our next one. C. X plus 6, x plus 2 squared. All right, so we have x cubed, positive x cubed. 2 squared is 4. 4 times 6 is 24. Our degree is 3 because x is squared times x makes x cubed. Our zeros are at negative 6 and at negative 2 because we got to switch the signs. So positive x starts low. We're at positive 24. So we're going to come up through 6. We're going to double back at negative 2 because it's square and then go up through 24. So hit y equals, change what's in y1 to that one. Leave your zeros at 40 and negative 40 from the first problem. And just go ahead and graph it, see what it looks like. Make sure it works. Okay, so let's look at the next one. So the x plus 6 is squared. So, but now we got this negative out front. So our degree is still 3 because x squared times x makes x cubed, but we got the negative out front. And then 6 squared is 36. 36 times 2 is 72. But we got the negative out front, so we got to make sure we multiply the negative 72. So our thing is negative 72. Negative xi starts high and goes low. So we're going to start high at negative 6. And at negative 2, we're going to double back at 6. So we're going to start high. We're going to double back. We're going to go back down through 2 and go down. It's going to look something like this. This may not be exact, but it's just an estimation. So please go ahead and graph this in the calculator. And when you need to hit the negative, make sure you hit the negative, not the subtract sign, or you will get an error. Negative is right next to the decimal button, which is next to the 0. In the middle of the calculator. Okay, now looking at this one, we got x to the third power, x cubed times x makes x to the fourth. So our degree now is 4. Our zeros are negative 4 and positive 2. Positive x even look like that. All right, so now negative 2 cubed. Negative 2 cubed is negative 8. Times 4 is negative 32. That's not our low point. That's just our y-intercept. So negative 4 and positive 2. So it's positive x. So it starts high. It might come all the way down. And now, because this is cubed, it's going to do something like this. There might be another hump in it, but we don't see. These are the only ones they give us, but it's going to look something like that. Take the time to graph it and make sure you get a graph that looks like this. Okay, now let's look at this one. We got 3 factors, 1 is squared. So you got x squared times x cubed, giving us x to the 6. When you multiply the same base, add the exponents. So our degree is 6. Our zeros are 0 because x cubed equal to 0, x plus 4 equal to 0, and x minus 3 squared equal to 0. So that's how we get 3 zeros or 3 factors. We get -4 and we get +3. So -4, 0, and +3. It's x to the 6. It's positive x even, so it starts high and ends high. And we have multiplicity at 0 and at +3. So it's going to do something like start high, come down. It's going to do some kind of switchback. And then at 3, it's going to double back. It's going to look something like that.
Please proceed to your next class.
Our intercept is 0 because this x 0. So you don't have to worry about the constants because this doesn't have one. So it comes through the x-axis. Okay, so I pulled this off of Delta Math. This is not in your notes. But what you don't have in your notes is leading coefficients. So let's talk about that. So, like always, we're going to figure out the leading term, the x-intercepts or the zeros or the roots, and then we're going to figure out the y-intercept. Okay, so let's start with the leading term. Multiply your x, but this is squared. This x is squared. So x squared times x squared times -3. This leading term gets multiplied to the x's because it distributes to every term. So our leading term is -3x to the 4th. Okay? So now our x-intercepts. We set x plus 1 equal to 0. We get x plus 1 equal to 0. Subtract 1, subtract 1. We get x is equal to -1. We set x minus 4 equal to 0. Okay, so I'm skipping a step here. Let me do this. X minus 4 quantity squared equals 0. To get rid of a square, you had to take the square root. The square root cancels out the square, so you're just left with x minus 4. If you see the square in parentheses, that changes everything, and you'll have something different. But I looked on the Delta Math. I didn't see the square inside the parentheses. So I'm just going to go on with this. So we get x equals 4. That's my 2 roots, my 2 x-intercepts, my 2 zeros. And now for the y-intercept. The y-intercept, you multiply your constants, but don't forget to square it. -4 squared. So for the y-intercept, it's 1 squared times -4 squared. But don't forget about the -3 out front. Most people will forget about that. So -3 times 1 times +16 equals -48. And that is my y-intercept. And we will go ahead and sketch the graph on the next slide. Okay, now that we drew our x and y axes, I put the x-intercept -1 and 4 in orange on the x-axis. My y-intercept is -48. I put that on the y-axis. Our leading term, -3, -x even, goes down and ends down. So it's going to go up. It's going to rebound at 1. It's going to dip down and come back up at 48. And then it's going to come back down at 4. So -x even ends down.